Part 6. Determine the relative uncertainty of hydrochloric acid molarity. So in this part is a little bit complicated. I will put it here. So calculation of relative uncertainty hydrochloric acid molarity. Now, for this one, you have to identify the tools that you use during the experiment, especially to measure something. So we have already list in here. Volume of water, you use measurement cylinder. Volume of hydrochloric acid, you use measurement cylinders, and also you need to use burette. Titration, you use burette, which is plus minus 0.01, and then you use hydrochloric acid to the volume is a volumetric pipette. Volumetric pipette plus minus 0.1, and then this one you just delete, ignore. We just focus to these two tools. Okay, so first we are going to identify the absolute uncertainty of volumetric pipette. Okay, so the absolute uncertainty of volumetric pipette is plus minus 0.1. The next one, you have to find the percentage uncertainty of the volumetric pipette. The formula is easy. You just put absolute, and then you divide with the value, and then you times with 100%. So absolute is this one. We'll put 0.1 value. Okay, because volumetric pipette, we measured the hydrochloric acid, the volume of hydrochloric acid, the original one. So you have to know what is the volume of hydrochloric acid in the original one. Oh, 20. So I put 20 and then times with 100. So when I want to calculate it, 0.1 divided by 20 equals, and then you have to times with 100. So it means 0.5%. Okay, so that's the percentage uncertainty for volumetric pipette. Okay, the next one is we have to find the percentage uncertainty for the second tools, absolute uncertainty of burette. Now in this one we have 0.01. After that, find the percentage of burette. Again, absolute divided by value times 100%. So absolute is 0.01. Value itu reverse to the average volume, NaOH. So in this term, I will use 39.74. So 39.74 times 100% equals, okay, 0.01 divided by 39.74 divided by, and then times with 100. So it becomes 0.03%. After that, you find the total percentage uncertainty. So it means you total this percentage. So 0.5% times 0.03%, and it's equal 0.53%. Okay, after you find the total percentage uncertainty, you can find the relative uncertainty of hydrochloric acid molarity. The formula is total percentage, and then you times with the value of molarity. So for example, 0.53% you times with, okay, let's check one of the molarity. Okay, so this term is 3.97. 3.97. So 0.53 divided by 100 and then times 3.97. So it's equals, it's equals 0.02. So this is the relative uncertainty of the molarity. Now if you want to go to the HCl one, you want to find the percentage of volumetric. Okay, take a look the formula. Absolute divided by value. So equals, open the bracket, absolute is 0.1 divided by value. Value of the hydrochloric acid, how many? Just take a look. Oh, 20. Close the bracket and then you times with 100 and you produce 0.5. For this one, we can use the similar numbers. Okay. Now, the percentage uncertainty of burette, we have absolute and then divided by value. Value represent the average volume of NaOH. So equals, open the bracket. Now, the absolute uncertainty of the burette is 0.01 and then you divide it with the average volume. Click the average volume here and then close the bracket and then times with 100%, so you produce 0.03. Take the black plus sign and then you produce all the percentage uncertainty of the burette. Don't forget, you have to put percentage. The total percentage you just add it, equals, open the bracket, go to the volumetric pipette percentage and then you add with the burette thingy, close the bracket and you got 0.53. Okay, the last one, if you want to find the relative uncertainty of molarity, you just click equals, open the bracket, go to the total percentage. Remember, because this is percentage, so you have to times with the molarity of hydrochloric acid, this one, close the bracket and you have to divide with 100 because the molarity of hydrochloric acid you have to multiply with the percentage. Enter, you got 0.02 and then you just drag it and you got 0.02 and 0.01. Okay, so that's the calculation of the relative uncertainty of hydrochloric acid molarity.